Hello everyone, good evening. Good evening and welcome to day 15 of our AI with NVIDIA masterclass. Good evening all. Good evening and welcome to day 15. Am I audible? Can you guys see my screen? Can I get some response in chat box? Good evening all. So in this particular session we are going to deal with a project which is going to be brain tumor detection with the help of a pre-trained model. So this is a perfect use case for a pre-trained model because when you have tumor data set and all, the data available for you will be very less. Okay, so it is better to go with, in such cases it is better to go with our pre-trained models. So we'll be going in that way. Okay, so that is going to be the ideology of this particular session. So can we continue? Can we start with the session? Can I get more response in chat box? Yes. Can I get more response in chat box? Good evening all, very good evening. So welcome to day 15 and the project we are going to see today is brain tumor classification. It's the third project in our entire session. And it is a brain tumor classification using the pre-trained models. So let us see pre-trained model brain tumor classification. So what is the objective? Detecting brain tumors using CNN involves training a model to classify brain images as either tumor present or tumor absent. That is the entire idea. Okay, so as you know, okay, earlier we have done some 50,000 images with 43 classes. Huge amount of data set. We have done a first project which is traffic sign classification. If you also go for dog or cat classification, you could, in the same way, you couldn't have 60,000 images. You can have, the number of sample increases, the best or better the model performs. Okay, but when you go for this brain tumor, we are actually limited with the amount of data we have. Okay, so only few amount of data is available with us. So in such case, what are we going to do? For example, if I just show you the particular directory of brain tumor. Okay, so we have a data set, we have a yes and no data directory. This is the actual directory which has nearly 150 images of tumor S and no images 150. Okay, sorry, 100 only, very less. So very short or very less number of images are available. We have it in Jetson Nano as well. That's where we are going to train as well as do inference. So these are tumor induced brain images. Okay, so the amount of data you have is particularly very small here. So that's why we prefer a method which is going to be using pre-trained model. So the first step and initial step is data collection. You have to gather a data set of brain images which includes both positive case with tumors and negative case without tumor. And these images can be obtained from medical database or through collaborations with healthcare institutions and all. And the data processing. So we are going to clean and process, okay, based on some normalization, resizing, augmentations will be done, and the labeling is done based on the keras. Then we split it into parts. You can go for model architecture, so you can either go for a CNN based from scratch, or here we prefer a pre-trained model, MobileNet V2 version. That's what we will be using. Then we go for training the model with a particular optimizer and train the model for some epoch. Then we will be evaluating its performance as well. The entire thing we are planning to do in TensorFlow in this particular session. Okay, so as you all know, let me connect to our Jetson Nano using the SSH protocol. So I'll go for SSH-L. Okay, so what's the command for going? You can go for SSH-L. Get me, guys? I think I have forgotten. Can you guys tell me? SSH-L, the port number, colon local host, right? Colon 888. Then pantech at 192.168.0.100. Okay, so we have connected now. We have a file. So now what I am going to do is I'll change the directory into BT. And here, as you can see, I have some inference image with me. I'll remove one thing. I'll remove rm-rf. The BT detect, it's a sample file which I have used for just testing out. So I have removed that as well. Also, we have some 2 files which anyway it is let it be. So you know that at the beginning you can see that there is a particular folder with the name of BT dataset. So let us move into that BT dataset. Okay, so inside of that you have yes and no folder. So if you move into yes, you get all the list of images of yes, as well as if you go into no, you will be able to get all the images of no. So this is the list of training images we have. So we come back. Okay, so let us do one thing. We go for a Jupyter notebook. Good evening all. Good evening. I hope you guys are following, right? So I am going to build this entire model from scratch. I am going to build. Are you guys interested in following it? Can we code actually? So don't get confused. We are actually using SSH connection and we are connected with our Jetson Nano. So I'll copy this and let me open a browser window. We paste it. Okay, so for example here, as you can see, okay, so let me just go and create a new Python 3 file. Okay, fine. So here, for example, let me go for, this is the command they have given. Why are you asking why Jupyter? Because Jupyter has a lot of options. If you want notebook, you have to go for Jupyter notebook. That's why it's not simply Jupyter. Okay, so I'll give a name, Tumor training code. Okay, it is going to be training code. So we start with import TensorFlow as TF. Okay, so from TensorFlow.keras.preprocessing images, we import image data generator. Okay, so that has been loaded. So the data loader has been ready. So now it's time for us to use it to load the data set. So it is something like our data loader and image data directory from our PyTorch. So here I go for image data generator. So I can call something known as flow from directory. So flow from directory, you can pass multiple parameters here. So the first parameter I am going to pass is directory is equal to BT dataset. That's the folder name. Then our target. Okay, so you can go for a target mode. Target size, I can reshape it into 224, 224. That's a common shape. Then let us look at what else do we have in this parameters. Okay, target size is fine. Then class mode should be binary. Batch size we have to enter. We go for a class mode, binary. Then what else? We have to go for a batch size of 32. Okay, so this is the entire data set will be loaded now. So it found totally 254 images from 2 folders, right? For example, data dot classes indices, you get 2 folders, no and yes. So your folder no has been termed as 0 here, yes has been termed as 1. So if you want to just take a peek of your data, you can use enumerate, pass the data inside, and then the entire thing you can pass it inside next. So you are creating a iterator and then viewing next. So this is belonging to a class 0, and then you have images, okay. So for example, if you want to take a peek, you can just go inside first index, you can view the parameters of 0 dot shape. So what does this give? It is giving you 32 images, okay. So in a batch you have 32 images with 224, 224, 3. So let us take one image. So this is a single image, okay. So what I'm going to do is, this is a feature of that image. Let me go for import matplotlib dot pyplot as plt, and then I'll go for plt dot imshow, and then we'll pass this. And then we go for plt.show actually to view the image. So sometimes you may need to add show. Okay, so this is what it is. So you can add a color map equal to gray. So you can see it in a grayscale. So it is pixelated one, which you can see the image. Every time I run this, I will be getting a new image. Okay, so are we clear with the loading part? Are we clear? Can I get some response? Can I get some response in chat box? Are we clear with the loading part here? Let me do one more thing. For example, here I'll do the same thing. I'll just take this, cut it off. Okay, so we go for first image, first label is equal to next of enumerate. So that will be able to, you can also use iter to iterate and get over your data. Okay, then your first image is equal to your first image of 0. Then first label is equal to first label of 0. And what you can do is next you can go for the same thing, plt.imshow. You can just pass your first image, and then you can also add plt.axis. You can switch it off, we don't need it. And then you can also use plt.title, and the title will be your f label. Okay, so running this, so this is 0, this is 0 which is disease absent, this is 1 which is disease present, which is the tumor present data. Okay, so this is the data loading part. Are we clear? Can we now go and take our pre-trained model? Yes. From directory no path given. What is this? BT dataset. I am currently in this directory. I have BT dataset folder here. Okay, yes or no? That is taken from there only. Okay, our file is here. It's in the current directory. Are we clear, guys? So next we are going to go to the model loading part. Okay, so let me go and pick the model. So first, for that we go for a base model. So the base model is equal to tf.keras.applications. We go for the MobileNet model. Okay, so MobileNet v2, and then the input shape is equal to 224 3 color channel. Then you can exclude the top by include top equal to false, weights equal to ImageNet. Fine. So this is what the features is going to be. So let it actually download. It requires some downloading, right? So it will be loading. So once that is done, I have to set the trainable as false. Okay, so we want to freeze some of the layers. So we set the initial layers to freeze by making it non-trainable. Okay, yes guys, good evening. So continuing here, I create a model. So the model is going to be tf.keras.sequential. Okay, so I'm going to concatenate a lot of things now. Please look at it. So with this model, I can add our base model. Okay, then model.add. We go for a layer which is called as tf.keras.layers. global average pooling 2D. Okay, so there is something known as global average pooling 2D layer. Let me explain with the documentation of its performance. So we perform this global average pooling, then we go for TF. Okay, same model dot add TF dot keras dot dense layer of 128 neurons, and the activation is ReLU. Then we go for model dot add TF dot layers dot dense. Sorry, we go for a dropout layer. Okay, so we go for 0.2 here. Then finally we go for model dot add TF dot layers dot dense. Okay, 1, because it is a yes or no classification problem. Am I correct? You have to just go for a binary classification. So 1 neuron is enough. We can go for activation of sigmoid. You can also run it in your collab. That's okay, guys. And one more thing, only few days is left. You can still convert this masterclass into 1 month certified internship on NVIDIA with AI. So if you join, you will be getting all these benefits, and it includes 30 days of recorded sessions, 30 days of PPT, 10 exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of access to LMS course, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificate. So all these things you could get it at a discounted fee at just 999. The registration link is posted in chat box. It's available in description. If you guys are interested, you could register and get all these benefits, and you could successfully register and get the course along with the dataset, code files, downloadables, previous day records, PPTs, all these benefits with weekly live sessions as well. Okay, so continuing. So we have a sigmoid. So this is going to be the final layer. So let us first combine all these things. So we create a sequential, we add a base model. Okay, spelling mistake, I hope so. It is keras.layers, right? Here also it should be keras, we are missing. Sorry guys. Fine. So we can go for summary of the model. So you should be able to get this summary. You have a mobile net which has something like 1000, 10,000 lakh, 10 lakh, 22 lakh, which is 2 million, 2.25 something, 2.25 million parameters. Then we have these parameters on our output. Also you can check your base model summary. So that would be your mobile net V2's particular locations, right? So this is the convolution layer, a batch normalization layer, then convolution depth-wise. As we know, it performs convolution depth-wise and point-wise operations to focus and then interpret. And this will be really great because, as I told earlier, this model MobileNet has this depth-wise and point-wise, which splits the image and then focuses like zooming, mark the important parts and then work. And that will be really helpful when you have MRI images, brain tumor and all. A part of the brain only have that tumor, right? So this model will be really great on adapting to this. So now we go further. We will be using this model, which is going to be combined with base model and our architecture. So going with the compilation part, as we know, we can go by calling model.compile. Okay, so when I compile, I have to go for an optimizer, which is going to be tf.keras.optimizers.atom. So this is the optimizer. Then the loss function is equal to tf.keras. I think we can also use this as well. Atom loss function is equal to binary cross entropy. Then the matrix is equal to accuracy. Okay, everything is ready. So anything else left, we can go for a model to train. If you have another set of data, you can also split it into testing part for evaluation. I think I can prefer going in the same way. Like with this, we can just go and work with it. Okay, so we are going to train since the data is very less. We can go for model.fit. I'll pass the data inside with the number of epochs is equal to 20, maybe 15. I think we can run, right? So can we train the model now? Can I get some response in chat box? Can we start the training portion? Can I get more response in chat box? Can we start with this? Yeah. So let us start the training. If there is no error, it will run. Okay, so as you can see, 1:15, it is going to start. You have to use separate data for training and testing. For testing, I'll be using a data which is collected from internet. I'll be randomly downloading and using that for inference, because that will be a good way, right? So I have two images which has been downloaded from internet, which is completely new data for this model. So it has to perform to get the result. As you know, it is better to train on some other device. Okay, so it is telling you that the resource has been exhausted. Okay, there is a problem with your Jetson actually. Earlier I was able to run. Okay, I think we can go and try this method to reduce the logits. Maybe that can give us some free memory. So instead of entirely going for binary cross entropy, we could adjust this from TensorFlow tf.keras.losses.binary cross entropy. So from underscore logits is equal to false. Anyway, we have to freshly run from the model scratch, create the object, compile it. Now let us try to fit. You can do in Collab, no issues. I think we can even download this, upload to Collab, train it, and then take the saved model file to work. Especially here, as you can see, the memory allocation issue happens, out of memory issue. So the memory became a problem here. Maybe we will check any issues from our side in the coding part, or else we can train it somewhere else and do the inference here. Let us do one thing. We'll freshly restart the kernel. Load the data set. So we'll just take directly the model, make it false trainable, define the layer, compile it, okay. So let us try to run the particular model. Otherwise there is also another loophole which may cause the issue. We will try to sort that down now. As you know, like the Jetson is not meant for training, especially, even though the dataset size is small. I think some other things are also allocated in our Jetson. So let me try to clear some memory and come back. In the meantime, are you guys clear with the working part? Because this is going to be same. You are just going to save it. So that should be able to execute and get us the result. Okay, only the model file will be saved. Yeah, so now we are able to train. Okay, so the training actually starts. Let us wait for it to complete. Okay, so it has started. Can you guys see it? The model training has been started. There are a lot of websites. From websites only we are collecting data set. So you can search for Kaggle. Google dataset search is a search engine. You can check that for collecting data set. Okay. Also, one more thing, guys. I have forgot to add one thing. I'll interrupt this. I don't know whether it will continue or not. Anyway, we have to just store it in history so that we can later see all the parameters, how the training has been done or not and all. Okay, so I'll firstly try to summarize this and run. Let us see whether now it runs or give us the same issue. Okay, so we'll see if it starts. So when it goes for history, we can actually view the accuracy and loss. You can plot for every epoch. It will be storing the history in this variable. So it's better to go in that way. I haven't shown you guys regarding that in our previous classes, so I prefer I can show. Yeah, now it's running. Let it train. So guys, still okay, you can convert the master class into 1 month certified internship on NVIDIA with AI. So if you join, you will be getting all 30 days of recorded sessions, all 30-day PPTs, 10 exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of access to LMS course, assignments and tasks, weekly live sessions, resume building, mock tests, internship and participation certificate. So all these things you could get it in a discounted fee at just 999, and the registration link has been posted in chat box. So you can register. It's available in description. It's pinned in chat box. You could register and get all the benefits. So looking at the training part, it is going beyond 5 epoch. As you can see, over the time, this pre-trained model training on my data, the losses keep on decreasing and the accuracy is keep on increasing. You can you please send the link of your Kaggle? Can you upload in chat box? I'll just check and tell you a smart way to load it. Can you send the Kaggle link, Madan, Mr. Madan? So once the training is completed, you can view the history. We'll see, and then you can ask the model to save. Okay, save it as brain tumor detection .h5 model. Okay, we'll save it in that way. Then we go for an inference code where we write the inference code. Okay, so the model training has been completed, 15 epoch has been completed. You can run more than that to make it nearly 95-97% accuracy. So look at this history. Okay, so you can call dot history in it. So you will be having a dictionary which has the loss value and accuracy value for every epoch. So what you can simply do is you can go for plt.plot. Okay, so I'll set a title, plt.title, which is going to be loss over epoch. So your x-axis is going to be you can use range function between 1 comma 16. It will run till 15, and then you can pass history in y-axis, history dot loss value, and then you can go for plt.show matplotlib. I haven't run, so let me go for import matplotlib, pyplot as pl. Can go for calling the loss function. So this is a loss. At epoch 1 it was high, so over the time the epoch, when it reaches 15, the loss has been decreased. You can further tune it to go beyond that as well. So similar thing you can also do for accuracy from this history. So you can go for loss over accuracy over every epoch. So if you have given for validation data, that will also available here. We haven't given, so that will be able to get you, and you can view that as well. So this is accuracy over epoch. There is a fluctuation and then it was great anyway over the time. So let me go and save this model file. As you can see here, we don't have that .h5 file, so let me just run this. And now, okay, so let me refresh. As you can see, we get this bt detect.h5. So now I'll create a new Python 3 file. So I'll save this. The part here is over. So I'm going to create a new file for brain tumor inference code. So here we import TensorFlow as TF, and then the entire idea here is I want to give a path, okay, from the user, which is the folder where the particular file is available, or the new image. So it should be able to detect and give us the result. So let us go for import matplotlib.pyplot as plt, then import pill. Okay, from pill we import image, then import numpy as np if required. Fine. So the model you can call TensorFlow.keras.models.load model. Okay, so pass that bt detect.h5 model. So this will load the model. Then I'll create a function pre-process our image, so that would get the path. Okay, so once the path has been given, you can use pill to open the image. So it is image.open your image path, just the path. Then you can perform image.resize 224, 224. Then you can turn the entire thing into array here itself. Okay, so from here we go and do something like image equal to image.asType inp.float32 divided by 255.0. remember, we are transforming it to 255 because it will be normalized between 0 to 1. So if length of image.shape is equal to 2, Okay, so if it is length is 2, we have to actually add an extra dimension because this don't have a particular patch size. So we go for stack, where you have to add the image multiplied by 3 and the axis is -1. So you can just stack it over it one by one. And then the image, we also need to expand the dimensions, expand dimes, pass the image, and you have to just go with 0 here, don't go with 1. That's why we have to transpose in yesterday session. So finally we return image as well. So this will do the pre-processing. Okay, so the path, image path is going to be, we'll leave it for now. And then the image is equal to pre-process image and pass the image path. Okay, so once it has been passed inside, we can go for prediction is equal to model.predict. You can pass your image inside, so that will make prediction. So the class of prediction is equal to the prediction greater than 0.5, it will be given as true, which means you can convert it as type of integer. Okay, so if it is less than 0.5 based on threshold, if it is less than 0.5, it will give false. Okay, so then it will convert it into 0. So based on that, you can decide 0 or 1. So now we will also load the image again using image.open. You can pass your image path inside, and then we are going to use one thing which is plt.im show image, and then color map equal to gray. Okay, so from here onwards we go for plt.axis, we set it off, then if the class predicted of 0 is going to be 1, then I would tell it as result is equal to tumor detected, else we can give result equal to new tumor found. You can set a title, plt.title, which is going to be the result, and then finally you can go and add your plt.show to this entire process, plt.show. Okay, so we have to give a path, then only this can run. It will give error now, so that the image is not found. So I have infer.jpg. Okay, so this is a normal brain image, I hope so. Okay, so this infer.jpg is a new image from internet. So I'll pass infer.jpg inside, and the kernel I'll just interrupt for now. So now we run this, let the model, let it load the particular file, bt detect.h5, then try to make the inference out of it. It will take its time. Once finally it will be showing you the result, okay or not, whether it's a normal one or a tumor induced one. So are we clear till now, guys? Can I get few more response? Why it is so silent in chat box? Are you guys following? It's a simple one. We are going completely hands-on, so it is a better way for you to understand as well. Okay. So attendance link has been posted. You can take. You can do in the same notebook. Okay, so I'm just trying to do it in a different notebook. No issues, because what I am trying to tell here is you have saved a model file. I am opening a new file and I am loading that. Still I was able to get the result. That's what we are trying to show. Okay. Okay, it hasn't been started yet. I think we need to have some more print statements, because we don't know whether it is going into the detection part or not, because it takes a time for inference, because generally this inference will be time consuming. So that's why in couple of days we will be starting. Okay, the resource has been exhausted. I mean, this guy is running, we'll just shut down let it be like remove all the memory from here so that we can make inference. So I have mandatorily typed it in a single code so that I can just, instead of this infer.jpg, I can give a command input, save it as a .py file so the user can use it to run. So it will ask for the location, okay, and then it will run. So this takes lot of time and source space and all. That's why we will be converting to this to TensorRT version. Okay, so TensorRT is a particular type which does faster inference on NVIDIA CUDA. So for that we will be looking for it later on. Okay, which is we'll be dealing it in a couple of days. Tomorrow we discuss about YOLO model for object detection. Then day after tomorrow we will be looking at the image segmentation model. Okay. Okay, we made some mistake it seems, especially where here in the resizing it seems. Maybe we have to give it as a tuple, that could be a problem. So first it's loading the model, then going for pre-processing the image, then it will make prediction, then we should be able to get a result. Okay, I think I have made few more. Expand dimensions. Simple spelling mistakes. When I was writing the code, along with that I had to look at the chat box. It was a tedious task. That's why we prefer here, if you use multiple cells of cell, you can just run this, so the loading part won't be running again. Then you can go for pre-processing in another cell. I was trying to save it as, okay, this path has been image path. So I think till here it has run. So the prediction has been made. Okay, so let us run it here, the remaining part. So here it should be image path. So let us view the result. So no tumor has been found. Can you guys see it? So we will do the prediction here and do the inference there. I'll give another image. So I have my second image, which is infer2.jfif. Okay, so this extension, okay, you can't view it. Let us go for first do one thing. We'll load that image. First I'll change this into one minute. Let us go for image path. img path is equal to image.open. So the file name is actually infer2.jfif, and first we are not going to do this inference out there. Let us view that image. Okay, we have already loading here, so this should be the path actually. So this is the image. It's a tumor induced image, as you can see. Now I am going to make inference in this infer2. So I'll just change it back to its original form, and I'll be passing the path above. Okay, so I'll just cut it. I think I can just cut it off, paste it here itself. Let us run. So infer2.jfif, and let me run this, and let us view the result. It is running. It will make prediction, and it will show with the title as well for us whether tumor detected or not. You can do multiple predictions and check as well. For internship students will be providing. Okay, so the training has to be furthermore fine-tuned. As you can see, it is giving us the prediction no tumor has been found, but it is a tumor induced image. maybe look at the class of prediction. So here we have that, right? So it has been predicted as 0. Anyway, it should be predicting as 1. So we have to further fine tune, because the model here what we had earlier was 93% accurate. So you have to further fine tune, take it more than 95, 98, and also that it can perform well. So that's how we make the inference, and that's this project is. So we have successfully completed this. We have to further fine tune. So you can fine tune in another way or in some other resources in your particular systems, and then take that trained model and load it here. But when you are doing this task, you have to make sure that this what we are trying here is Python version, as well as the TensorFlow version is actually 2.6, I hope so, 2.4 or something. And nowadays lot of things has changed in your latest version. So now you can detect all at once. For that you don't want to create this expand dimension and all. You can store everything as a batch, send it together, you will be getting an array of prediction. You can do it. It's called as batch prediction. You can even pass a folder name, so everything will be taken from that folder and you can make prediction in that way as well. You can do it. I'll be adding that for the internship students. So that's it for today, guys. Thank you. Thanks for watching. Tomorrow we will discuss about YOLO model, then image segmentation day after tomorrow, then we will be discussing about TensorRT conversion and all. So we'll see there. Thank you. So just a couple of days is left. Only a few days is left. You can still convert this masterclass into 1 month certified internship on NVIDIA with AI. You will be getting 30 days of recorded sessions, PPTs, project files, VIP community group for doubts and internship updates, confirmation letter, access to LMS course. If we increase the epoch to 20, it will show tumor, because earlier I tried with 20 epoch, it was predicting good. Now I have stopped with 15 due to time constraint. It was not predicting well. You have to further fine tune. Okay, try to run with 20 epoch or more than that. You should be able to get a model with nearly 99% accuracy. You can take it and make prediction. Caleb. So thank you, guys. Thank you. You can still get this. The link is available in chat box and description. You can go to 100%, but if it is 100, it may go for overfitting. Around 98, 99 will be great anyway. You do it in other, like if you do it in GPU with Google Colab and all, this will run in just 10 to 15 seconds. It will run all the 15 epoch. It's very small actually. You can try, load and get the result. Thank you all. Thank you.